Hello friends, today we are going to see how to remove duplicates from a sorted linked list. So let's see an example. See, this is the sorted linked list and in this linked list A is the head node. So you can see B is the duplicate node here and C is the duplicate node which is repeated 3 times and B is repeated 2 times. So what we are going to do, we are going to remove the duplicates. Means we are going to remove the second occurrence of B and we are going to remove the second and the third occurrence of C. So our answer will be A, B, C and D and then null. So this is how we remove duplicates from sorted linked list. Now let's see how to do this. This is the code for removing duplicates from the linked list. Now, remove duplicates is the name of the function and head of the linked list is passed as a parameter. So the head node of the linked list is passed as parameter. Now, these are the test cases on which we are going to execute this code. Now, node star P equal to head means P will point to the head node. In this case, the node A. And in the third linked list, this is the head node. Okay, so P will point to A in this case. Now, node Q is just declared and further in the program, I will tell how this Q is used. So, let's go inside this while loop. While P is not equal to null and P points next is not equal to null. So what these two conditions mean? The first case is, suppose P is equal to null. Means if the linked list is null, then obviously there is no question of duplicates. Means you can go inside the while loop only if P is not equal to null. If P is null, we will come outside the while loop. Okay, and let's go to the next condition, that is the second case, and it is written here. And P points next is not equal to null. See, this means there is only one node in this linked list. And if there is only one node in the linked list, obviously there are no duplicates because there is only one node in the linked list. So in these two cases, if the linked list is null or there is only one node in the linked list, you go out of the while loop. Okay. Now, let's execute this code for the third case. Okay. Now, P is not equal to null and P points next is also not equal to null. So, we go inside this while loop. Now see, if P points data is equal to P points next points data, means if the data of the current node is equal to the data of the next node. If it is true, that means there is a duplicate node. And in our case, always understand that the duplicates will always be consecutive. The duplicates will always be consecutive. Because this is a sorted linked list. So the duplicates will always be in series, in a consecutive series. That is why we are checking whether the data of the current node is equal to the data of the next node. Yes, it is equal to the data of the next node in this case. Okay, so we go inside this if condition. Now, Q equal to P points next. So what we are going to do here, we are going to unlink one of the nodes. We are going to unlink one of the node, and that node is the second occurrence of A. That means the next pointer of node P should skip the next node and should point to the second next node. Okay, to the second next node. That means, see here, P points next. This is the first next and this is the second next. Okay, so for this P, the first next is the duplicate element and this is the second next. Okay, and we want this P to skip the first next. So we store the second next element in the pointer Q. Okay, so this is Q. Now Q equal to P points next. Now let's go ahead. Now in this case, see here, if Q equal to null, that means now Q is pointing to null. So this is the end of the linked list. If Q equal to null, then that means you have to point the next pointer of P to null, because as you can see, P points next equal to null here. So now P points next equal to null, and as this is the end of the linked list, you have to break from the while loop for this third case. Okay, now you will understand this code perfectly when we solve for the fourth case. Okay, this fourth case includes all conditions. So let's execute this code on the fourth case. So as you know, A is the head of the linked list. So P will point to head. So head is passed to this parameter here. So A is passed to the parameter and now P will point to head. So P is pointing to A. Now let's go inside this while loop. While P is not equal to null and P points next is not equal to null, obviously P is not null and P points next is also not null. Okay, so let's go inside. See, if P points data is equal to P points next points data. So we are checking whether A is duplicate. So whether the next node of A contains A? No, it is not. So A is not duplicate here. Okay, so this if condition is not satisfied. So we will skip this. Okay, and we will come out. Right, and after we come out of this if block, we again check whether the data of P is not equal to the data of the next node of P. The importance of this line I will explain in the further while loop. Means the while loop for the element C uses this if condition. For all other cases, this condition is satisfied, but for the repetition of C, this condition is not satisfied. So in the further while loop for C, I will explain the importance of this condition. Until that, you just consider this condition and just check the data. Okay, so here whether A is equal to B, no, it is not. So this condition is satisfied, means A is not equal to B, the next node. So we move to the next node. So P is equal to P points next. Okay, now let's go in the next iteration of this while loop. So check whether P points data is equal to P points next points data. Yes, in this case B is equal to B. So check q equal to p points next means you want to skip this duplicate node and you want to store the address of the next node of this duplicate node so that the next pointer of p can be pointed to q. Okay, because if we delete this middle node, then we will lose the link to this node, right? Then we will lose the link to this node. So there should be some variable to store the address of C. That is why we are saving the address of C first in Q. Means we are saving the address of C in Q, and after that we are unlinking this node. How we are doing that? Check. Now the next pointer of P points next equal to Q. So next pointer of P will be equal to Q. Okay, this is the way we are doing it. So in this way this node is unlinked, and now B is pointing to C and this duplicate is removed. Now the question about this if condition, obviously after Q was pointing to C, Q was not null, so this if condition is not satisfied. So I directly went to this statement. Okay, let's check if P points data is not equal to P points next points data. Yes, B is not equal to C, so you can go inside this if block. So P is equal to P points next, so P moves to the next node, so P now points to C. Now let's go to the next while loop, means the next iteration of this while loop. So again check whether P points data is equal to P points next points data. See here, yes, C is equal to C. This is P points next, so C is equal to C. That means we can go inside. So again store the address of the second next in Q pointer. So P is pointing to C and the second next means this is the first next and this is the second next. So this second next address will be stored in Q. Okay, and check if Q equal to null. No, it is not null, so this condition is not satisfied. So we directly go to the next statement. So P points next equal to Q. This is the time to unlink this duplicate. So P points next equal to Q. In this way this duplicate is removed. Now here is this condition. The importance of this condition is to be told now. See, if P points data is not equal to P points next points data. So even if we have removed one duplicate, but still there is one more duplicate. That means there are more than 2 occurrences of C. Okay, see, in previous case B was occurring 2 times, but in this case C is occurring 3 times. Okay, which is why even if we have removed one duplicate of C, but still there remains another duplicate. That means in the cases where there is more than 2 occurrences, means 3 occurrences, 4 or 1000 occurrences for example, in those cases even if we remove the first duplicate, the job is not yet done. Means this if condition checks whether the job is done or not. Obviously in this case one duplicate is removed, but still there is one more duplicate, so the job is not done. And check here, P points data is not equal to P points next points data. So here check, P is C, data is C, and P points next is also C. So P points data is equal to P points next points data. It is equal, means this condition is not satisfied. And if this condition is not satisfied, that means that the job is not yet done. Means still there are duplicates of that element of P, of the element which is pointed by P. Okay, so P will remain at the same position until all the duplicates are removed. Means as this condition is not satisfied, means as the job is not done, P equal to P points next will not be executed and P will remain at the same position. It will not go next and it will remain at the same position until all the duplicates are removed. So P is at the same position and we go to the next iteration. Now check, if P points data is equal to P points next points data. Now whether P's data is equal to P points next points data? Yes, because C is equal to C. Okay, so we go inside this if condition. Okay, so we go inside this if condition. Now Q equal to P points next means we store the second next. So Q will now store node D, means the address of node D. Okay, because see, for P this is the first next and this is the second next. Okay, and we store the address of second next, as you know that. So and then see whether Q is null. No, it is not null. So P points next equal to Q. So P will point to Q. So now is the time to unlink the second duplicate as well. Okay, so unlink that duplicate and go to right. So it will point to D. And now check whether P points data is not equal to P points next points data. Yes, C is not equal to D, means the job is done. So P equal to P points next. This will be executed now. So P will go to the next node. So P will come here. Right? And now again go to the next iteration. But this condition P is not equal to null is satisfied. But P points next not equal to null is not satisfied because here the next is null. Okay, so we will come out of this main while loop, right? And in this way we have removed all these duplicates, right? So let's check the fifth case. You can practice this case for yourself because this is the same case as the fourth case, and the sixth case is a special case in which all the elements of the linked list are same. So the answer of this case will be only that element, means only A will remain and that will point to null because all the elements are same. So please practice this at home. And there is a simpler version of this code which works only for two occurrences, So for only two occurrences, means only one duplicate, I have prepared a video which is a simple code, and if you watch that video then these concepts will be more clear. And you can get the full code for this on my GitHub link, that is github.com/Vivekananda44. Okay, I have mentioned the link in the description below of the code, so please check this link. Hey friends, please subscribe to my channel as I post algorithm videos every day. And if you want a video on any particular topic, then please mention in the comment below. Thank you.